3D cleaning, shaping, and obturation of root canals have always been the desired goal of endodontic treatment. However, most root canals are not round in cross-section, making 3D endodontic preparation with rotary files a difficult and challenging procedure. The self-adjusting file system, based on a hollow file that adapts itself to the irregular shape of the root canal, overcomes many of the current drawbacks of rotary file systems. The SAF is composed of nickel titanium and designed as a thin-walled, pointed, lattice-like cylinder. Operated with gentle vertical vibration at the rate of 5,000 RPMs, the abrasive surface of the file grinds against dentin to achieve a gradual circumferential enlargement of the root canal. An irrigation bar built into the hollow shank enables the dentist to irrigate simultaneously during shaping and facilitates superior cleaning and disinfection. The file does not impose its shape on the canal. Instead, it will custom fit itself to any root canal anatomy and shape it in a minimally invasive way, removing more contaminated dentin while conserving healthy tooth structure. The SAF is available in 3 standard lengths and 2 different diameters. The patented ReDT3 handpiece head delivers sonic speed vertical vibrations combined with slow, low-torque rotation. Dentin is removed by grinding the file in a rapid in and out movement against root canal walls. Additional rotation helps change the file's axial orientation during treatment to ensure dentin removal is uniform circumferentially. ReDT3 head is available in 2 configurations, making it compatible with a variety of contra-angle handpieces and motors. The irrigation tube should always be connected to the file and pulled taut. Doing so reduces the rotation speed of the file, minimizing the risk for file separation. Sodium hypochlorite is a potent corrosive. To prevent cumulative corrosion damage, wipe and lubricate the head after each treatment. There are 2 options for operating the SAF system. The first one is by the all-in-one endo station, and the second one is by the Vitia irrigation pump system, together with an existing endodontic motor. The endo station is an advanced endodontic motor that enables working with all leading motor-driven endodontic file systems, including SAF, rotary, and reciprocating. It is combined with a built-in irrigation system, providing constant low-volume irrigation during endodontic treatment. Plug in the power transformer, connect it to the endo station, and switch it on. The endo station has an E-type micromotor compatible with various contra-angle handpieces and is operated by a foot switch that controls the endo motor and the irrigation pump simultaneously. Connect the micromotor and foot switch plugs into their designated sockets. Choose the desired mode of operation by pressing the mode key and toggle to the program you wish to update by pressing the program key. The SAF system mode includes 3 programs, of which the first is fixed and the other 2 are programmable. The rotary and reciprocating modes have 10 programmable programs each. Connect a contra-angle handpiece suitable to the selected file system, adjust the gear ratio accordingly, and perform a torque calibration by pressing the calibrate key. To operate the SAF mode, first set up the irrigation system. Fit the irrigation line cassette into its tray. Insert the bottle holder into its receptacle. Fill the bottle with the desired irrigation solution and place it in its holder. Insert and secure the short end of the irrigation line into the active cap, fit it into the bottle, and close the cap. Connect the lure connector at the long end of the irrigation line to the analog connector of a disposable irrigation tube that will later be attached to the self-adjusting file. The irrigation system can be controlled by the pump on-off key at the main unit, as well as from the foot switch. Adjust speed, gear ratio, and irrigation flow rate according to the information found in the SAF System Clinical Guidelines Manual. The built-in timer counts the working time and should be reset whenever a new root canal is approached. When working in rotary and reciprocating modes, the irrigation system is disabled. For rotary mode, connect the suitable contra-angle handpiece, perform calibration, and adjust the speed and torque control levels according to the file system used. Rotation direction can be adjusted by the forward reverse key, and the type of auto reverse can be chosen using the reverse type key. For reciprocating mode, once the contra angle has been connected and calibrated, adjust the speed and the rotation angles. To avoid clogging of the irrigation line, at the end of each workday, rinse the irrigation system by running clean water, using the rinse key for at least 30 seconds, then dry by pumping air through the system. More information regarding the operation and maintenance of the endostation can be found in the Instructions for Use manual. The Vitia peristaltic pump is designed to provide constant, low-volume irrigation during endodontic treatment. Connect the electrical charger and charge the batteries until the LED light indicator changes to green. Using the funnel, fill the reservoir with the desired irrigation solution and secure the cap. Connect the foot pedal plug and silicone tube to their designated sockets. Turn the system on using the master power switch and set the flow rate to the desired value with the plus and minus buttons. Irrigation is toggled by clicking the foot pedal, and the integrated timer display helps to keep track of treatment time. Endodontic irrigants may form crystals and clog the tubes. To prevent this, replace the irrigant with sterile water and run the pump on maximum output at the end of each working day. To classify the case, we need to check for the first instrument to bind at working length. SAF 2 mm should be used to treat wide canals presenting apical size 35 or larger. SAF 1.5 mm can be used with no additional glide path in simple canals presenting apical size of 20. Canals that only allow a number 15 or 10 file to be inserted to working length will be classified as medium complex and complex canals respectively. In these cases, a glide path must be created that will allow the free insertion of the SAF to working length. The minimal compressed size of the SAF is equivalent to a number 20 file with a 4% taper. A matching glide path can be created using various instruments, from basic hand files and Gates Glidden drills to latest generation 9-tie rotary files. More information regarding different options for glide path can be found in the SAF System Clinical Guidelines Manual. The best way to verify the adequacy of the glide path is to try to manipulate the SAF manually to working length before proceeding. Use light pecking motions to insert the SAF to working length. If resistance to insertion is encountered, stop and re-establish glide path. Excessive apical pressure at this stage may damage the file. Treat each canal using light pecking motions for 4 minutes with a recommended irrigant flow rate of 4 ml per minute. When used properly, the file rotates to change its axial position only during the outbound stage of the pecking motion. Prior to obturation, gauge the prepared canal using gutta percha master cones or 9-tie hand files to determine final canal dimensions. Final canal dimensions are expected to be 2 to 3 ISO sizes larger than the initial apical size. More information regarding obturation after SAF preparation can be found in the SAF System Clinical Guidelines Manual. The SAF mode of operation is unique and can neither be classified as step back nor crown down. This single file shapes, cleans, and disinfects the entire length of the root canal simultaneously. To get used to this concept, adopt the system gradually into your clinical routine. Start from simple, more accessible teeth with straight canals, then move to molars. Isolate the tooth using a rubber dam. Prepare a standard access cavity and determine your working length. Check for the first instrument to bind at working length. This canal was classified as a complex canal and NiTi rotary file system was selected to prepare a tapered glide path. Information regarding additional glide path options can be found in the SAF System Clinical Guidelines Manual. Verify the adequacy of the glide path by inserting the SAF manually to working length. Most of the canal shaping is accomplished during the first 2 minutes of operation. Completing the full 4-minute cycle allows the irrigant to thoroughly clean and disinfect the canal. Final apical dimension was gauged using a standardized gutta-percha master cone prior to obturation. With the SAF, the final canal shape remains consistent with its original anatomy. Research shows that the SAF mode of operation results in an exceptionally clean and smooth root canal wall surface, even in oval and irregular shaped canals. This facilitates better adaptation of the root canal filling material. Higher percentage of gutta-percha filled area, and markedly superior root filling push-out bond strength. The combination technique of obturation, demonstrated here by Dr. Solomonov, combines lateral cold compaction in the apical region with vertical warm condensation in the middle and coronal parts of the canal. This technique allows for better control of the apical region, avoiding excessive sealer extrusion. Information regarding how other common obturation techniques work after SAF preparation can be found in the SAF System Clinical Guidelines Manual.